Good day, students. Today we're going to look at solution to number 3 on page 129. So page 129 of your booklet. That's book 1, chapter 2, systems of equations. So we're asked to solve this system. Okay, we're asked to solve by using what's called a multiplication. I'll abbreviate multiplication addition method. Now the multiplication addition method is often known as the elimination method because your objective is to eliminate one variable. Now if I add these together right away, you'll notice I will get 4 and 5 are 9x plus 14y equals negative 4. So that didn't help us at all because nothing was eliminated, right? So remember, when you use this method, you want something to be eliminated. So how do I go about eliminating a variable? Well, the first thing we're going to look at is eliminating, let's say we decided to eliminate the x's. Well, I know they're both positive, so I'd have to multiply the top equation by a positive and the bottom by a negative, or the top by negative, bottom equation by positive. And I want the same coefficient, the same number in front of the x. So if I pick the top to multiply the top equation, say by 4, I would have to pick negative 5 for the bottom equation. Now what does that do? Well, let's have a look. Okay, that will give me, let me just write down the equation again. So now when I multiply, let's look what happens. I get positive 4 times positive 5, so that'll be 20x. Positive 4 times positive 8 is positive 32, and of course positive 4 times negative 2 is negative 8. And on bottom I will get negative 20. Negative 5 sixes are 30y equals positive 10. So now look what I have. Look what I have in front of the x here. I have a positive 20. Look what I have in front of the x below it, a negative 20. So when I add both of those, now then I draw a line under both equations and add, okay, it will eliminate the x terms, because those two added together will give me, of course, 0x or simply 0. I don't need to put in 0 or x. Now when I add the other two, I get 2y, positive 32 and a negative 30. If I add the last two numbers, of course, I get a positive 2 as well. Now it's very easy to solve for y. Divide each side by 2. So y is equal to 1. Now, that's just one choice. I could have done other things. I could have multiplied the top equation by negative 6 and the bottom one by 8 to eliminate the y. So there's, this is not just the one way to do it. I chose to eliminate x using positive 4 on the top equation multiplying by positive or negative 5 on the bottom. So it's by choice that the x's were eliminated. Now you can repeat this process if you want and actually eliminate the y, solve for x, or you can simply sub back into one of the equations. And most students do that. They'll take this and sub y equals to 1 into one of the equations, and it doesn't matter, so I'll just pick the top one. 5x plus 8y equals negative 2. Right? So really we could call this method the multiplication addition substitution method, because the last step we do is we're subbing back in, right? So 5x plus 8 times 1 equals negative 2. So I sub 1 in for y. So 5x plus 8. Now bring the 8 to the other side and solve like you would any time you have an equation of this type. Minus 2 minus 8. So 5x equals negative 10. Isolating x by dividing by 5 gives us x to be negative 2. Therefore, I have a solution now of negative 2, always x first, y. So it looks like this is my solution. And again, how do I verify that? You can check And how do you check? By substituting that into the original equation. So I'll take the first equation, 5x plus 8y equals negative 2, substituting negative 2 in for x and positive 1 in for y. I get negative 10 plus 8 equals negative 2. So negative 2 equals negative 2. That works. It works in the first one. Let's see if it verifies it in the second equation. 4x plus 6y equals negative 2. 4 times negative 2, which is negative 8, plus 6 times 1 equals negative 2. 6 times 1 is 6. Negative 8 plus 6 is indeed negative 2. So that also works. Therefore, I know now that definitely negative 2, positive 1 is my solution to this system of equations. So that's the overall solution to number 4 on page 129.